Good afternoon. I hope I am audible, visible. My screen is also shared. Okay. Okay. Good afternoon, dear learners. Welcome to the ninth session of the course Fundamental of C. And today we are going to discuss about two-dimensional arrays. In last session, we have discussed about one-dimensional array extensively, and we have seen several examples related to declaration and initialization and some application also about arrays. And then I have left you with an introduction with 2D arrays. Okay, so now we are going to just revisit what we have understood about 2D arrays, and then we will delve into the detail of the topic. Okay. So the guidelines, as all the learners are like aware, is to maintain discipline for smooth conduction of this interactive live session. All the learners are required to type in their name with enrollment number and the program name on the chat to mark their attendance. You can raise your questions after completion of the session. Okay. The learning objective for today's session is the learners will be able to understand about 2D array and how we can declare and initialize a two-dimensional array, how we can access the elements of 2D array, and what are different operations we can perform on the two-dimensional array. Okay, how we can display and take input from the user and store it inside two-dimensional array, how we can pass an array element to a function. So this time we are going to introduce functions, and in the next lecture also will be based on functions. So I'll just briefly introduce you all to functions, those who are like conversed with it. There are certain rules for using an array, which we will learn. Okay, so this was the agenda for today's session. Now let's recap of what we have learned about two-dimensional array. So before two-dimensional array, what is an array? I have mentioned that array is a homogeneous collection. Homogeneous collection means it can store the elements which belong to a certain data type. Okay. And then it is a collection of values, collection of elements. And then all the elements which are stored are statically stored. Okay. So there is a definite size of an array, right? And we use index number to access a particular element or a value stored inside an array. So when we have got an index which refers to the position of that of that element inside an array. So when we are talking about one-dimensional array, we only use one index. But when we talk about two-dimensional array, we use two indices. Okay, so I have told you that a two-dimensional array is a matrix-like structure. Okay, or it's a table-like structure which contains a set of rows and columns. Okay, so when we talk about a matrix, it is a 2D two-dimensional structure which makes it grow in two directions or two dimensions. First is the column-wise direction, and second is the row-wise direction. Okay, so it has got rows and columns. So if we want to access a certain element stored inside a two-dimensional array, we have to specify the row number and the column number. That makes two indices. Okay, that makes row and column as the indexes which we need to access a certain element. For example, when we talk about a matrix, so when we talk about a matrix, if you want to point to a particular element, how do we point to this particular element? By using its row number and column number. So since the indexes start from 0, okay, when we start counting indices, we start counting from 0. So the first row will be referred as a row number 0, and the first column will be referred as column number 0. So it means the very first element, which is at the top left corner of the matrix, will have this index 0 0. Okay, and the last index out here will be m and n. And now what is m? M minus 1, and the last column number will be n minus 1. So it means that we will have two indices, m minus 1 and n minus 1, which will make us point to the last element, which is at the bottom right corner of the matrix out here. This one. So this will be m minus 1, n minus. Okay. And if we want to like represent any particular element, we will say that it is an element aij. Okay, so here what is A? A is the name of array, and I is the row number, and J is any column number. Right. So what about I? I will lie between 0 to m minus 1, where m is number of rows. And what about J? J will lie between 0 and n minus 1, where n is number of columns. Right? So we can, when we write this term aij, we mean that an element present in array A at row number I and column number j. Right? So if I say that there is an element at A12, okay. So if there is an element at A12, it means that it is present at a row number 1 and column number 2. So we can also say that it is the second row and this is the third column, because we are referring as we start counting from 0. So if the column number is 2, it means it is third column. And if we say that row number is 1, it means it is second row. Okay. So I hope this concept is clear to you about how we are going to access a certain element inside a two-dimensional array. Right? So the two-dimensional array is not linear in structure, because one-dimensional array is a linear structure, but two-dimensional array is a non-linear structure. It's a tabular structure. Okay. So we can say that a two-dimensional array is an array of arrays. Means if we store arrays, one-dimensional arrays, one on top of each other, it will become a two-dimensional array. Okay, as I mentioned, the element of the array will be identified by using two indices, one for row and one for column. Okay, so two-dimensional array is also known as a matrix. In mathematics, we all have studied matrix, so it is identical to that concept. So if we want to access a particular element inside an array, we will use two subscripts. Subscripts means we'll write like this. Or if I talk in programmatically, I will write like this. Both are same. Either mathematically I can write like this, or symbolically I can write like this, and programmatically I will write like this. And both are same. It means ith row and jth column. So an array will have an element which is present at an ith row and jth column. So that is why we call them two subscripts or two indices, right? So here we have shown it diagrammatically. So if we mention ARR21, then ARR is the name of the array, 2 is the row number or row index. Okay, row 2 means third row, and column 1 means it is second column. So if you can see that this element is present in second column and third row, right? Because why? Because we start counting from 0. Okay, so I hope this is concept is absolutely clear to all the learners. If we want to declare a 2D array, so to declare a 2D array, as I told you that for declaring one-dimensional array also we have to follow the same process. First, we have to mention the data type because arrays are derived data types. We have to specify the primitive data type before we can declare an array. So why? Because all the elements will belong to that data type. So that array will be collectively for that data type. Okay. So if we declare an integer array, it means all the elements will be of type integer. If we declare a float array, all the elements will be of type float. So it is necessary to declare the data type first and then the name of your array variable. Okay. And then here we mention the size. Size in terms of how many rows and how many columns. So before you can store the element inside a table or a matrix, you have to tell the compiler how much memory to reserve. Okay, how much memory to book. So by doing that, you will have to specify the size. So size will be integer value. Okay, so here you will specify how many rows you want, and the second dimension will be how many columns you want. So here there are two dimensions. So two dimensions will tell you how much size we have. Okay, so it means that, but in memory, how it is stored? If you look at memory, do you think that in memory also it creates a tabular structure? No, it's a linear structure. In stack, it stores in form of a stack. Okay, it stores like this. So here it will store the first row, then it will store the second row, and here it will store the third row. Okay, so it will store in a stack manner only, but representationally we call it a matrix. That is why we call a two-dimensional array as array of arrays, means an array of one-dimensional arrays. So this is a 1D array, this is a 1D array, this is a 1D array. So you pile it up, 1D array or 1D array on top of each other, so that will give you a two-dimensional array. Okay, so it means that after if we say that if we declare such an array, so what we mean, we will have 5 rows and every row will have 3 columns. So how many total elements will you have? 5 into 3. So you will have 15 elements. What will be the index? The index will start from 0, 0. And what will be the index of the last element? M minus 1, N minus 1, right? So it will be 4 and 2. Okay, so this is M minus 1, that is 4, and this is N minus 1, that is 2. So that is how you will store it. Okay, so if you write this command, this statement, int my array 5 3, so it will create a matrix of structure with 5 rows and 3 columns. So the rows will start from 0 1 2 3 4, and the columns will be numbered as 0 1 and 2, total 3 columns. Right, clear? So this all we have studied in the previous lecture. Just to revise, I was doing. Right. Now, how to declare a 2D array? We have just seen how we have declared a 2D array. So first we have to mention the data type. Then we have to put the array variable name, and then number of rows, and then number of columns, and then put a semicolon here. For example, int num 10 5. So if we write int num 10 5, int means all the elements will be of type integer. Num is the name of your array, and the number of rows will be 10, and number of columns will be 5. So total, how many elements will you be able to store? Maximum 50 elements, 10 cross 5. So that is, number of elements will be maximum 50. You can store less than 50 elements, no problem in that. I'm not saying that you have to store 50 elements. You can store less number of elements also. But the maximum memory which can be allocated to you, or which has been allocated to you, is to store 50 elements, each of type size integer. Okay, so if you want to calculate how many bytes you have booked by writing this statement, for that you have to multiply the number of elements by the size of your data type. So if I say the size of the data type is 2 bytes for integer, you all know this, that for integer the size provided by the compiler is 2 bytes. So if we can say this, that for every integer element we will be provided 2 bytes. So for 50 elements, 50 such integer elements, how many bytes will be like provided? So we will be given 100 bytes. Okay. So we will be given 100 bytes to store 50 elements, 50 integer elements. Right? Till this point, are things clear to all the learners? Okay. So for most of you, things are quite clear. Then coming to initialization. So what is initialization? Initialization is to assign the first value to any variable to an array. So the first method is by using a list of values. So the first method is by using a list of values. So for list, how we can start? So first we have to write the declaration part, but we will not here end it with semicolon. We will continue writing the assignment. Okay, so we have used this assignment operator equal to, and like we did in one dimensional array, we will use curly braces and provide comma separated values uh, uh, for the values which we need to store inside the array. So since the maximum number of elements which we can store in an array of 3 cross 4 will be 12. Okay. So if we say that I want to store, let's say, 12 values. So, and those 12 values will be 0 1 2 till 11. So how it will be stored then? So if we look at it programmatically, how will we be able to store it? So let's say we create a table structure. So we will have how many rows? So we will have 3 rows and 4 columns. Okay. So let's say we will have 4 columns. Okay. And we will have 3 rows. Okay. Like this. So we will have 3 rows and 4 columns. So now how will we store it? It will store it row wise. So 0 1 2 3, and then 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is your table or matrix which will store it. But do you think that inside memory also it will store it like this? No, it will not store it like this. It will store like this. It will store row wise. Okay, so first it will store values till 0 to 3. So this will make it first row. Then it will store values from 4 to 7. Then it will store values from 8 to 11. So this is how it will be actually stored inside the main memory. But programmatically, virtually, or for our illustrative purposes, we can use it in a matrix like structure. Okay. So here uh, in the memory, the array is represented as a contiguous block of memory locations, as I told you, and all will be having the same data type, right? Now there is another way of initializing the array. We can use a nested pair of braces. Nested braces means this particular group is the first row. This particular group of value will be the second row, and this particular group, the third group, will be for the third row. So each set of your nested braces or inner braces will correspond to a row. Okay, so since these are the three sets which we have created uh, inside this initialization, so for every set we can say that it is for one single row. So this makes it much more easier to understand. Instead of simply writing 0, 1, 2, 3 and just put close your curly brace. So curly brace inside brace will give you an appearance, more understanding, more clarity that how these elements will be stored row wise. So this nested pair of curly braces will tell that this is for a row. Okay, and then you separate it by comma. So inside all the elements are separated by comma, and then this group is also separated from another group by a comma. So row 1, comma row 2, comma row 3. We will have the groupings like this. So this method is much more easier to understand. Okay, so C allows both the ways of initialization for your two-dimensional array. Right? So I believe till this point, this array declaration, array initialization is clear. Both the methods are clear to you. First is without nesting and second is with nesting. Right. So and then we have got like another way of initializing the array elements, and that is by using loops. So using any loop, we can use for loop, we can use while loop for the initializing the values inside 2D array. So here we have done declaration. So this is declaration. There is no initialization clubbed in it. We will do initialization using a loop. How to run the loop? So the outer loop will correspond to number of rows. So this outer loop is for row. Outer row loop, and then for every row, each column means for every row we will have one all the columns. So this inner loop is for the column loop. Okay, so the outer loop will run for every row, and this inner loop will run for every column of every row. Okay, so how will it work? So we have declared two variables, I as the outer loop for the outer loop, and for inner loop we are using j. I have already taught you nested loops, so you know how it works. Okay, so I will start from 0. Okay, so the first value is 0. For the 0th row we will have to take all the values of j. So I0, j0. I0, J1, I0, J2, I0, J3. So it will go till 4, till the J's value is less than 4. Okay, so then you continue collecting the values of Xij. So we are calculating Xij actually. So Xij is I plus J. So I plus J will be the value for every Xij. So here Xij is X00. So X00's value will be 0 plus 0, that is 0. Then Xij will become X01. So X01 is I plus J, 1, because the formula says so. Okay, I'm not just adding because I have written a logic like this. If my logic would have been into, then we would have calculated like that. Clear? But since we are using I plus J, we will be calculating I plus. Now 0 plus 2, X02 will be 0 plus 2, that is 2. X03 will be 0 plus 3, 3. Right? Then what will happen? Your J value has exhausted because you have reached a value, last value as less than 4. As soon as it will become 4, it will come out of the loop and go executing the outer loop. So now the outer loop will increment from 0 to 1. Again, J will be reset to 0. So now we will be having 0, 1, 2, 3. So this will fill up the first row. So this will fill up the row number 0. So in your matrix, the first row will be filled by these values 0, 1, 2, 3. Now what will happen? In this I becomes 1 and J is again 0. So which element are we talking about? X10. X10 is 1. Then X11 is 2. Then X12 is 3. Then X13 is 4. So the second row will be populated with 1, 2, 3, 4. Then what will happen? You will come out of this inner loop and increment i's value as 2, because you have to run the outer loop till I is less than 3. So 2 is the last value which is less than 3. So again the same business, 0, 1, 2, 3. So 20 x20 will be 2 plus 0, that is 2. X21 will be 2 plus 1, 3. X22 2, x22 will be what? 4. And x23, which will be the last value for your matrix, will be 5. So you will have values as 2, 3, 4, 5. Right. So this is how you will populate the matrix by using a nested for loop in case of 2D array. But in case of 1D array, we don't require nested loop. You will only have one loop, one nesting. So is this clear to you? Is this logic clear to you, how it is going to work? Right? Okay. So some of the learners are responding that they were able to understand, which is good. So now in the same way, we will access the elements in 2D array. So here, in order to access the 2D array, you will have to write the array name and the dimensions specified here. So I and j value. So for accessing any element aij, we will be writing, we will be specifying, or we will be supplying the row number and the column number. So row index and the column index, if we give, then we will access the particular element inside array. So if I say that x21, so x21 means what? It is the third row and it is the second column because we start counting from 0. So if we are referring to 2, 1, okay. So here there is column 1, column number 0, 1, 2, 3, let's say, and so on. And here we have row number 0, 1, 2, 3, and so on. So if someone says that go and fetch x to 1, okay, so then the third row and the second column. So this is what we are pointing to. So this element will be termed as x to 1. Okay. So we are accessing the elements and we are printing the values. So we are printing the values after accessing them in this example. So this is called row major traversal, means outer the the row major traversal means we are iterating over the rows first and then iterating over the column. Okay. So we are iterating over the rows first and then iterating over the column. So the outer loop, when in row major traversal, outer loop, the outer loop is for rows and the inner loop is for column. Okay. Sorry. So inner loop is for columns. So here we have declared an array, a 2D array of size 3 and 4. And then we have stored the elements here. So how will the elements be structured? So let's say we will have 3 rows and 4 columns. So we will have 3 rows. Okay, so we have created 3 rows and then we have created 4 columns. Okay, so these are your 4 columns. And in this table, we have stored values 1, 2, 3, 4. It means for the first row, 1, 2, 3, 4 values are stored. In the second row, elements 5, 6, 7, 8 are stored. And then in the third row, elements 9, 10, 11, 12 are stored. So this is your matrix. The name of the array is matrix. Okay. So now we are running outer loop because we are doing row major traversal. Outer loop is for rows, inner loop is for columns. And we are printing all the elements. So the first element will be row 0, column 0, 0. So matrix ij will be this one. So it will print 1. Okay. Then after that, it will uh, increment j. So it will become 0, 1. So 0, 1 element will be 2. So it will print 2. Then row number will still be 0. Column number will become 2. So it will become element 0, 2. So element 0, 2 is 3. Then element 0, 3, which is 4. So it will print like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It will print elements like this. Okay, so this is called row major traversal. But what is column major traversal then? Column major traversal is when your outer loop is for column and the inner loop is for rows. So that is another way of accessing the elements. So let's say again the same elements we have stored here, but this time the outer loop and inner loop concept has changed. Outer loop is columns and inner loop is row. So outer loop is column, inner loop is row. So column, for the columns, the loops will run from 0 till 3. And for the rows, it's obvious, for every column, all the rows. Okay. So the rows will run from 0 to 2. Okay. So now how will it will print? It will not print like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It will not print like this. It will access the first row. Okay. And it will, it will first access the first column. So it will go to your first column. So this is your column number 0. So here j is 0 and I will go from 0, 1, 2. Okay. So it will print all the columns for all the rows of this column. So it will print the it will print which value 0 0, then it will print 1 0, because we are printing matrix ij. So matrix ij will be, I will be written first and j will be written second. Obviously you have to mention row number and then column number. So 0 0 1 0 and 2 0, these elements will be printed first. So it will print 159. Okay, so then what will happen? It will change the column index. So column index will be updated from 0 to 1, and I will run from all these values. That is 0 1 2, 1 0 1 1 1 2. So it will print a 0 1 1 1 and a 2 1. These values will be printed. Okay, so I hope you are able to understand how it will print. Okay, so that is called column major traversal, right? So this is 2 6 and 10. So it will print 2 6 10. Then what will happen? Again the column number will be updated from 1 to 2. Again I will run from 0 1 and 2, but while accessing the elements we will write 0 2 1 2 and 2 2. Okay, so it will print 3 7 and 11. And then lastly the column number will be, sorry, yes, the column number will be 3, and then again value 0 1 2. So which values you will print? 0 3, then 1 3, and then 2 3. So we will print 4 8 and 12 like this. So this is called column major traversal, where the outer loop deals with number of columns and inner loop deals with number of rows. Is this example clear to you? Okay. So hopefully the last example was clear to most of the learners. Then the different operations which we can perform on a 2D array. So 2D array allows us to perform different operations. The first is obviously traversal. So traversal can be done, or accessing can be done. We can use nested loops for traversing an element, traversing every element. So this 2D array we are using. So we have got a matrix as of 4 rows and 3 columns. Okay, so 4 rows means first row, second row, third row, fourth row. So it will print element, it will store elements row wise, 1 2 3 2 3 4 3 4 5 and 4 5 6, right? So it will store elements row wise, as I have already told you. For accessing you can use row major traversal. So outer outer loop will be for row, and inner loop will it will be for columns. Okay, so you have to print values like this: array %d %d. Why is that? Because both the indexes are integers. Indexes are always integers. Okay, so indexes are always integers. That is why we here mention %d %d. Correct? And then the value stored is also integer, because the data type of your array is integer. So indexes are always integer, no matter what data type your array is. Index cannot be 1.5 or 1.7. It cannot be. So we will have to mention which index we are printing on the screen. So if we want to print the index also, then we will use % here. Mostly we don't print the index on the screen, but if we want to print index, put their placeholder format specifier %d %d. Okay. So here it will print ij also. So here it will print I value of I, it will print value of j, and then it will print the value stored at that location. Okay, or that set of index. So that is again a single integer value. So your matrix has been created like this: 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6. So it will print and it will display the output like this only. In the same way, we can insert values inside a 2D array. So for inserting values inside a 2D array, again, we can have an empty array. So here I have not initialized my array. I don't have any elements stored inside array. I have just declared my array. So for declaring array, I have used this ARR33. So it is simply array declaration. Now we'll ask the user to store elements inside this array. And for doing that, I will run the loop and I will ask the value from the user which I want to store inside my array. Okay. So here I will tell the user to enter elements. So for entering, I will first declare that enter elements. So it will print enter elements. And then I will run the loop. So since it's a square matrix, so how do you come to know it's a square matrix? Because number of columns and number of rows are equal. So the outer loop will be for row and the inner loop will be for column. Okay. Right. There is some typing error. This statement has to be written here. Okay. So this uh, particular for I is equal to I less than 3, this has to be written here. It's not a comment. Okay. Till this part only it is comment. This line number was supposed to be written down. Okay. Don't confuse. So here for I is equal to 0, I less than 3, I plus plus. And so this was rows and this was columns. Okay. The J is we are using for columns. So we are saying that elements at particular index is now I'm scanning that value. So scanning that value, I will use %d. Here scanf function I will use and then ampersand ARRIG. Both the indexes I will specify. I hope you remember the 1D example where we have only written one index. But since it is a two-dimensional array here, I'll have to specify both the indices where I want to store that value. And then I will print it. Again, use the same structure, but this time instead of scanf, I'll be doing printf. Okay, so here I'm printing the values. Okay. So I'm printing all the values. Right. So here, what I have done, I have asked the user to enter elements. So this is scanf value 10, 20, 30, 40, 50, 60, 70, 80. All those indexes I have uh, been visiting and asking the user what to enter. So user has given 10, 20, 30. This is scanf value. And this is this value being stored in my array, which I accessed by using the same loop structure, but here we are using printf. So previously we have used scanf for entering values by the user, and the next set of loop is for printing those values which we have stored in the respective indexes. Okay. Where we use arrays. So arrays are basically data structures. Okay. So some student has asked that what is the application of array, right? That is what you are asking. So arrays are data structures. What do we use data structures for? Storing data in a systematic manner. Okay. So why we need to store data in a systematic manner? There can be different like objectives for storing data. We can run algorithms on it. Okay. We can save it in the database. Okay, we have to access it. So that is why reason for any algorithm, if we want to implement on a data set, we have to use data structure. So arrays will offer us to data structure, and these arrays can be used to simulate different data structure behaviors. Like we can have stacks, we can have linked list. Okay, you will study data structures and algorithms later. Then we'll be using stacked queues you can use. Then different data structures like graphs and trees we can create. Okay, so many other data structures we can use. We can create maps from it. So different data structures we can create by using simply arrays. And why do we create data structures? For storing data in a systematic manner. Why do we need to store data in a systematic manner? So that we can run algorithms on it. Okay, so there has to be a sequence. For example, in your storehouse, in your warehouse, okay, you store items, or in your kitchen you store items. So in kitchen, how do you store items? How do you store food items? Or in fridge, how do you store items? Do you lay it out in the open? You go to your kitchen and you will see items being lined up on the counter. That's the way we store things. No, there is a rack on which we put labels, right? You must have seen your parents putting labels on jars, like that it is for spices, it is for chili, it is sugar, it is salt, right? So we store that information, or we store that value in a systematic manner. So so what is the reason? Because if you want to cook some food, you have to access, it will be like easier for you to access if all these values are stored in a systematic manner. So in arrays we have got indexing, so that we can access the elements in a more convenient manner. Okay, so this is the applicability of arrays. uh Continuing, then how do we update a 2D array? So for updating elements, means modifying the elements, we have to do two things. First of all, we have to access that index, and then we will scanf and then print it. So by doing it, it can happen that value is previously stored somewhere. So updating means just replacing that value. Okay, if your array is empty, then also same logic will work. And if your array is pre-populated, the same array will be working. But if you want to provide a different index for updating, for changing the value, or if you want to update all the values, that is a different matter. Or if you want to update a certain value, then you have to specify where you want to update. So then you will ask the user to enter the index at which the previously stored element will be updated. For example, where previously salt was kept, now you want to keep sugar. So in that case, you have to point to that particular location. So again, a scanf is required, that enter the location in a matrix where you want to update the value. So you will scan that index. So your I and j will become that index. And then with which value you want to replace. Okay, so then your index will be updated by the new value. So when you write this, the previously stored value will be overwritten by the new value being supplied by the user. Okay, and for confirming it, you can reprint that array. Okay, so reprinting that array. So here with the output, you can understand previous logic worked. Okay, for inserting values inside an array. That logic worked. But after that, this thing happened, that enter the location where you want to update the value. So the user gave at 20, I want to update that value. So at 20, what was the value previously stored? It was 77. So now it was assigned as num value. So ARR IJ was being with the new value, that is this 70. So instead of previously 77, so the new value which was updated here is 70. Okay, so that is how this program worked, right? So you can also delete the elements in a similar manner. Deleting means you will replace it with null or empty value. So that you can do. Okay, so that is permissible. And then we can also pass element arrays. So here, this particular program gives an example where we are using printf and scanf to take input and print output for the array. So here we have declared a one-dimensional array. Okay, and then we are asking the user to enter an element, right? So using scanf, you can insert. It is also possible that so this topic of two-dimensional array is completed. Now we will discuss that how to pass an array element to a function. Okay, but before that you have to understand what is a function. Functions you have been using so far. So printf is a function. How do you come to know? Because in printf we pass certain arguments. Okay, we pass certain arguments. So functions are like characterized by a pair of round brackets. So printf, you have used scanf as a function. Okay, main is a function, right? So it means that we can also declare user defined functions for our own work. So every function, like in mathematics, we have got fx here. Okay, so x is called argument, and the value which is returned by the function is called the returned value. Okay, so there is a data type with which this value is associated, that is called return type. And the argument also belongs to a particular data type, that is called the argument data type, right? So you can pass the arguments and then function will generate output for you. Okay, so you can pass, for example, we have got a function called access. Access does not return any value. How do you come to know that? Because the return type of this function is void. Void means it will not return any value. Okay, so how do you declare function? You have to provide first here return value or return type, and then you will write the name of the function. Although we will discuss functions later in the next session, but since I'm going to discuss how to pass an array element to a function, I have to tell you this. So here name of function, and then put brackets and then argument. So this is how we declare a function. So here we can declare a function like void access. So it means access is the name of the function and void is the data type that value that function will return. So function is not returning any value. And then this is the argument which we are passing. So argument is int num. Okay. So till this point, is there any doubt? Any student is having any doubt, they can discuss about function basic. Okay. So here I am just passing an array I have not specified any size. And this is an example where I am passing an array, but I have also specified the size. Okay. Few things which are associated to array is pointer. Okay, so what is pointer? Pointer is a variable which stores address of another variable. But when it comes to array, the name of the array is the pointer to the first variable. Okay, so name of the array is the pointer to its first variable. What is pointer? See, pointer will store the address of the variable. But since we are pointing to the first element, let's say the name of the array is ARR, and the first element is written as ARR0. So if I simply say ARR, so ARR is a pointer to the first element of this array ARR0. Okay, or I can say the address of ARR0 is stored in the name of the array variable, which is ARR. Okay, so we can also pass pointers, array pointers. So array pointers are nothing but the name of the arrays. Or we can also store an explicit pointer, that is also allowed. Okay, so arrays can be passed to functions in different manners. Mostly we use function passing by value and passing by reference. So passing by value means we will simply pass the name of the array. So here, if you see this example, we are passing a 1D array into a function. So this is a function min array. Okay, name of the function is min array. And this min array function takes two arguments. First is array and second is its size. And the value which this min array function returns is integer. So min array is a function which returns integer value and it takes two arguments. First is array name and first is array and second is size. So here we are assuming that we have declared an array before and the minimum of the array is ARR0. So the first element of the array is the minimum. This we are initializing it. I is 0. Then we are iterating of the array from 1 to its size. Okay, so our objective is to find the minimum element inside the array. Minimum element inside the array. So what we are assuming? What is our assumption? Assumption is that the first element is minimum. This we are assuming. Okay, so in order to find the minimum element, what we will do? We will take the 0th element as the reference. So ARR0, we are going to take a reference. So let's say this number is, let's say 3. Okay. So there are multiple values which are stored here. Okay. There are multiple values which are stored here. So now what will happen? This is an array. Okay. This is ARR0 and this is ARR1. Our objective is to find the minimum value is stored inside the array. So how will you find? Let's say this is our point of respect where we are assuming that the first element is minimum. Now we will start searching for an element which is less than 3. So whichever value comes first, which is less than 3, I will designate it as the minimum. So right now my minimum is the first element of the array. So that is ARR 0. So I is 0 right now. For I is equal to 1, I less than size. Less than size means the last element will be size minus 1. That is why. So if minimum is greater than ARR I, then minimum is equal to ARR I. Means whatever your current minimum is, if it is less than any array element, the new minimum will be that new array element. So first we will compare 3 with 5. So 3 is less than 5. So no swapping. So minimum is still 3. Then you compare 3 with 7. So minimum is still 3 because 3 is less than 7. Now you compare 3 with 2. Okay. So now your ARR I is less than minimum, or we can say the current minimum is greater than ARR I. So what is the new minimum now? So new minimum is 2. So the new minimum is 2. Again, we will compare, continue in this loop till we go to size. Okay. So for then your new minimum is 2. Okay. Then you continue finding the next value. Okay. So again, you will compare 2 with ARR 9. 2 will compare with 9. So 2 is still minimum. 2 will compare with 1. So now new minimum is 1. Then again you continue further. Then you compare 1 with 0. So 0 is the new minimum. So, and this is also the last element. So you will come out of the loop. Okay. So this is one of the applications where you can use this array, right? So after this program, after this function, we have called this function from the main function. So main function will be the caller function, which can call any function. So we have created an array. So the minimum will be 3, right? So it will print the minimum as 3. So you will have to pass two arguments. First is the array and second is the size, right? So in call by reference also, we do similar thing, but here we pass the pointer. So pointer will store the array address. So instead of passing the array value, we will pass the address of the first element. Okay. So if for passing the address, we will use this address of operator. Okay. Or you can use the name of the array. So here 2D array also we can pass in a similar manner for in the function. So you can print the 2D array value, right? So there are certain rules for using array. First is declaration before we can use it. Second is indexing. We have to always refer to indexing values. And third is initialization. So initialization can be done after their declaration. So declaration will come first, then you do initialization. Or you can club declaration followed by initialization in one statement. We have to use size, bounds checking, passing arrays, these all things. Okay, so today we have discussed about 2D arrays. We have seen what are the different operations we can perform on an array, what are the rules associated with array, and how we use the array as passing to functions. So if you have got any doubt, you can ask in the chat, or you can access uh, these slides, right? You can ask what if you want to ask any question in the chat. So I'll ask some review questions. What are the different operations we can perform on 2D array? Who can answer? What are the different operations we can perform on 2D array? Yes, very good. Accessing, traversing. Yes, deleting, inserting. Yes, very nice. So some student has answered. Okay, printing values. Very good. Okay, you can pass array to a function in how many ways? Pass by values, yes, and pass by reference. Okay, all right. Thank you so much for attending the session and happy learning.